Nitration of aniline. Nitration is another example of electrophilic substitution reaction. Aniline on nitration with the nitrating mixture, concentrated HNO3, H2SO4 mixture, we get three products. A mixture of three products will be obtained in which nitro group is substituted in the ortho position, meta position and para position. We get orthonitroaniline, metanitroaniline and paranitroaniline. The amount of orthonitroaniline is 2%, metanitroaniline 47% and paranitroaniline 51%. Means we get significant amount of metanitroaniline also. Aniline, this amino group is ortho and directing group. Amino group is ortho and para directing group. But here we get, in addition to ortho and para, we get significant amount of metanitroaniline is also obtained. This is due to, in strong acidic medium, aniline, in strong acidic medium, aniline is protonated to anilinium ion. What is anilinium ion? This aniline being basic, it would protonate, add one proton and become NH3+. This is called anilinium ion. This anilinium ion with a positive charge on the nitrogen atom is meta-directing. This anilinium ion is meta-directing. That is why aniline on nitration we get gives metanitroaniline also, obtained along with the para and ortho. Even though amino group is ortho para directing, on nitration aniline gives metanitroaniline also. This is the reason. In strong acidic medium, aniline protonated to give anilinium ion which is meta-directing. So on nitration we get a substantial amount of metanitroaniline also obtained. Now, if you want to obtain any one of the mono nitro derivative as the major product, what to do? The activation effect of amino group should be controlled. Activation effect of amino group should be controlled by acetylation in the presence of pyridine. So what happens? This NH group is acetylated. COCH3 group is substituted. COCH3 group substitute the hydrogen atom and we get NHCOCH3. This is N-phenyl ethanamide or acetanilide. Acetanilide or N-phenyl ethanamide. This one on nitration. HNO3, concentrated HNO3, H2SO4 will give paranitro product as the major product. This would give nitro group is substituted in the para position. Paranitro acetanilide will be obtained. This paranitro acetanilide on hydrolysis, acidified or alkaline hydrolysis would give the product paranitroaniline. Hydrolysis takes place here, hydrogen is added here, OH group here, and what do we get? Paranitroaniline, and acetic acid molecule will be released. The role of pyridine here is to eliminate or neutralize the acid formed during the reaction. Pyridine is a base, so it would react with the byproduct acid and neutralize it, so that the equation will be directed in the forward direction. So aniline, in order to obtain paranitroaniline, what to do? The acetylation reaction should be conducted in order to control the activation effect of amino group. Then sulphonation. Sulphonation of aniline, another electrophilic substitution reaction. Aniline undergoes sulphonation with a concentrated sulfuric acid. So first we get anilinium hydrogen sulfate, that is NH3 plus HSO4. First we get an adduct, that is anilinium hydrogen sulfate. This is anilinium hydrogen sulfate will be obtained, and this would on heating at 453 to 473 Kelvin. We get the product NH2, and in the para position the sulfonic acid group, SO3H group in the para position is obtained. This is called sulfonilic acid. Sulfonilic acid is in equilibrium with another structure. Here it contains an amino group on one side and a acidic sulfonyl group, the sulfonic acid group on the other side. So here this SO3H group, this hydrogen is removed as a proton, and this H plus would be added to this NH2 group. The NH2 group being basic would accept the proton from here and form NH3 plus. So this structure sulfonilic acid is in equilibrium with another structure in which the hydrogen atom of the sulfonic acid group migrate from here to the amino group, and NH2 become NH3 plus, and this SO3H become SO3 minus. That is, a dipolar ion is produced, a positive NH3 part and a negative SO3 minus part. Such a dipolar ion formed by the movement of hydrogen from one part of the molecule to the other part of the molecule is called Switter ion. That is, sulfonilic acid is in equilibrium with a Switter ion configuration. Now, aniline does not undergo Friedel-Crafts reaction. Friedel-Crafts reaction also we know it's one of the electrophilic substitution reaction, but aniline does not undergo Friedel-Crafts reaction because during Friedel-Crafts reaction we use a catalyst, anhydrous aluminium chloride. Anhydrous aluminium chloride, the Lewis acid catalyst used in the Friedel-Crafts reaction, would react with aniline. This catalyst and aniline would react and form a salt. It would form a salt in which nitrogen atom, in that salt, the salt formed will be NH2 plus AlCl3 minus. This is the salt formed during the reaction. In this salt, nitrogen carry a positive charge and becomes deactivating group. So this positive species formed during the reaction will be deactivate the further reaction. So aniline does not undergo Friedel-Crafts reaction because of salt formation with a anhydrous aluminium chloride catalyst. That is the Friedel-Crafts catalyst. And this salt contain a positive charge on the nitrogen, hence it is a deactivating group. It deactivates the benzene ring towards Friedel-Crafts reaction.